Well, howdy everyone. What we've got going on today is I'm going to give you guys a quick 12-month review of the jaw crusher. I'm going to be going over alterations, I'm going to be going over specifics, and covering off just a couple of things that I've been quite commonly asked about it. I thought it's probably a good idea to do a bit of an overview or a look back on this machine and hopefully cover off some of those questions that are still getting posted on the original video. Now, since I first made this, there have been quite a few changes. The biggest change, and probably the most important one, has been these pulleys and the belts. So originally I was running A section belts, which are smaller than this. These are B section. I was originally running a 63mm pulley down here, and I was running a 190mm pulley up here, I believe, as the driven. That's changed. So the 63mm, of course, being smaller than this one here, didn't have a lot of surface area. There was not a lot of grip on those belts, which was a big issue in this case. We need to, especially being such a low speed machine, we need to have as much grip down onto those belts as we possibly can, which in this case required me to add a larger pulley and have a little bit more surface area for the belts to grip on. Now, of course, slightly altering the pulley sizes will change the speed of the machine, and on a small machine like this, I originally planned for it to be around about 200 RPM up here at the actual jaw itself, or the eccentric shaft. Now, being a small machine like that, I can actually get away with a higher speed. So what I've done here is, with these belts, upgrading my smaller pulley, my driver, would mean that I also need to make the driven pulley larger to keep that same RPM. In this case, I decided that I didn't really need it to be around that mark, so I went down in size for the driven pulley. So, this one was purchased new. This one was just one that I had laying around, so it sort of worked out really well. What I've got now is an 80mm twin B-section pulley driving a 125mm twin B-section pulley. And of course, on this old Honda engine, we have a 1:6, or a 6:1, I should say, sorry, reduction box. So assuming this engine is running at around about 2800 RPM, we can divide that 2800 by 6, which will give us around about 450 RPM, something similar to that. And then the difference between these two pulleys will then reduce it a little bit more, and we'll end up with just a smidgen over 350 RPM. Which is actually a lot better than the roughly 200 RPM I originally had. So for anyone looking to build a jaw crusher the same size, which is 200mm across and around about 125 or 150 mil opening in the top, around about that 300 RPM mark is ideal. So you can achieve that engine or that driven speed using anything. You could have an electric motor that you could run off this. You might have a standard Honda engine with a 1-inch output shaft on it that's got a pulley mounted directly to it. If you were to do that, you would of course need to have a center shaft. So if we had 2800 RPM coming off this pulley here, this thing's going to be absolutely flying. It'll probably shake the whole thing to bits. What we would need is a second center shaft. So we could put one, say here, mounted between two pillow block bearings like these. We could have a small pulley going to a larger pulley, right? Beside that larger pulley, we'd have another small pulley going to this larger pulley. I've seen them like that before. There's nothing wrong with doing them that way. It's just basically about reducing your pulley ratios to get roughly that right speed. And I would certainly recommend aiming for around about that 300 RPM. It works really well. Now, I've just gone ahead and illustrated an absolutely amazing drawing of the center shaft concept, so bear with me here, it's a bit rough. assuming we had another Honda or stationary engine that didn't have a reduction box on it like mine, remembering that mine has a 6-to-1 reduction box on it. So immediately coming out of my engine, if it's at 2800 internally, it runs through that reduction box and it'd be reduced by 6. So we can divide our engine speed by 6 immediately. If we didn't have that and we had any other sort of standard stationary engine or perhaps an electric induction motor that was around that 2800 RPM, what we'd need to do is add this center shaft. So if we had a 100mm pulley on the driver here, the output shaft of the motor, and we went to a 200mm pulley here, this is diameter, we'd reduce our speed in half, so we'd divide it by 2. If then on that center shaft we had, beside the 200mm, a little 80mm pulley driving our main jaw crusher eccentric shaft on a 320mm pulley, we would divide that speed again by 4. So just here we've divided it by 2, and then just here we've divided it by 4 again. So we're starting at 2800, dividing it by 2, we've brought it down to 1400 RPM on the center shaft. Then with the second ratio of pulleys, we've divided it again by 4, so that would give us around about 350 RPM at the eccentric shaft up here. It's a very simple way to do it, but you need an additional 2 pulleys, you need an additional 2 pillow block bearings, a center shaft, and you're going to need an extra 2 belts. So if you're running twin section belts. Once you've established your desired ratio and speed, you've worked out the diameter of the pulleys that you need, you're going to need to work out your belt length. Now it's a pretty simple process to do that, believe it or not. Let's just assume that we've got 2 pulleys here. One is 100mm in diameter and the other is 200mm in diameter. Forgot a 0. We need to know 2 important details: the circumference of each of our pulleys, and we need to know the distance between the centers of them. So if the distance between our center here is 500mm, center to center, we need to know the circumference of each of our pulleys. So to do that, we use a very simple formula, 2 pi r, which is 2 times pi times the radius of each pulley. The radius of each pulley is, of course, half the diameter. It's only the measurement from the center to the outside. So we know our radius of this one is 100mm. We know that our radius of this one from the center to the outside is 50mm. It's half the diameter. So from there, we can then use 2 times pi, or let's just shorten it down to 3.14159 times 100 for this one. That's going to give us a circumference of around about 630mm. Now, the belt doesn't make contact with the entire outside of the pulley, does it? It only makes contact with approximately half, or a little bit over half in this case. So we divide that 630mm circumference by 2, we'd get around about 315mm around just 1/2 of that pulley. We do the same on this side, and using the formula, because we know this one's half the size, we will be right to assume that the total circumference of the smaller pulley, 100mm, would be 315mm. We divide that by 2, so we've got around about 157mm of circumference around half of our smaller pulley, 157mm. So those are the important details of each pulley, and then we've got the center length here. So we're going to need 500mm between here and here. We're going to need another 315mm between there and there, another 500mm back to this one, and followed by 157mm to close us back off and complete that loop. So we're going to be looking at around about 1450mm, let's call it, of belt length. Now belts don't come in millimeter lengths, they come in inches. So what we need to know there is 1450, for example, and we're going to divide that by 25.4 millimeters in each inch. That will give us our belt length in inches. Belts are marketed with a letter to begin with, So for example, A23, I believe, is the smallest belt. So that's the small profile A, and then 23 inches long. Am I dyslexic? Why am I writing different numbers first? 23 inches long. In our case, we would need a belt of around about, if this was 1450 mil divided by 25.4, that would give us roughly 57 inches of belt length. We want a nice B-section belt for this to get as much contact surface area on each of those pulleys. So we'd need roughly a B57 belt. You don't need to get these numbers exactly right. Rough enough's good enough. You'd probably find, a B56 might fit perfect. But what you're going to do, of course, is leave yourself a little bit of room on your mounting bolts for your motor so that you can move the motor backwards and forwards and tension the belts as you need. So getting an approximate number on your belt length is all that you'll really need there. Something else that has changed is originally I had the 2 adjustment bolts here that I'd welded on. Now they weren't done very well. They were only small bolts, and that's just all that I had laying around. They broke very quick. So the idea of those bolts, of course, was you could tighten each side in, and that would push this toggle plate further back, or unscrewing the bolts, of course, would open up the jaw further, pulling the toggle plate back this way. What I've ended up doing is doing away with those, and I've made a couple of solid mounts. You're not going to be able to see them here because I can't really get the camera in there, but I've made a couple of solid blocks that actually sit in there between the back angle iron here on this funny angle and the actual toggle plate itself. To get a really good idea of what that toggle setup looks like, you're going to have to go back and have a look at the other jaw crusher video. I would hope that anyone watching this has already seen that one, and they're just coming here for a bit of additional information. But basically, having a solid plate like this and no adjustment bolts, that's fine in my situation, because currently I'm breaking it down to around about 1 inch minus. If I want it larger or smaller, that's fine. I've got a couple of other little plates here. I just unhook these 2 springs and put the different size plate in to then set the distance of the jaw slightly differently. As it is now, breaking it down to around 1 inch is perfectly fine for this setup. I did have it closed up more, and yeah, that made for some smaller material coming out the output. That wasn't very advantageous to me with the crushing plant, the way that it's currently set up. There's nothing wrong with feeding, 1.5 inch rocks or larger into my impact mill as it is. So I decided to open it up just a little bit more. Relieves a little bit of pressure off the jaw crusher, and it actually helps keep things moving through the impact mill when I run the material through the whole crushing plant. I've added this input tray. So, of course, not having this back, if you look back at the original video, there was only a small opening for me to pour the rock into, or to throw the rock into. Having this nice input tray is fantastic. As mentioned in a previous video also, this isn't the final resting place for the jaw crusher. It will eventually be mounted way up, roughly on top of the roof line up here, on a couple of big poles, and then it'll feed directly into a hopper, which will then have a vibratory feeder that will slowly trickle the ore into the whole crushing plant system. So where it's sitting now, that's just what it's doing. It's on a slight bit of angle. We do get a little bit of rock working its way back up out here. But this input hopper is awesome. It's still got a flap on top, so I can easily flick it up and jam my arm down in there if something's stuck. And finally, onto probably the most important piece of information, the flywheel. So what I've got here is 2 of my old brake rotors from the Nissan, and I've just welded them together. I've stitched them in a few places around the outside. I've got a taper lock pulley, an old one that actually no, it wasn't an old one. I bought it brand new. Just a single section pulley. I've welded the outside on. It's got a 32mm bush in it, and then I can clamp that straight down onto the shaft here, the eccentric shaft for the crusher itself. That, of course, will store momentum. That is so crucial when it comes to crushing rock. It's also a massive help when it comes to dealing with the issue of the slipping belts. Having that energy stored in that bit of a flywheel, even though it's only quite small, as you can see, having that energy stored there has completely changed how well and efficiently this machine operates. And if you're running a jaw crusher without a flywheel, well, I strongly suggest you make one, because it's going to make a huge difference. You'll be absolutely stoked with it. Aside from that, what's gone wrong with it? Absolutely nothing. It has been utterly fantastic. I have put a crap load of rock through this jaw crusher so far, and aside from those two little adjustment bolts in the back breaking, which I was totally expecting them to do, it has not missed a beat. It has been absolutely fantastic. So, would I make any changes in future if I was to build another one? Well, no, probably not. I'm really happy with having the petrol motor driving this machine. That's no dramas at all. I'm really happy with throw of the eccentric shaft. So keeping in mind that we've got 32 millimeter shaft on each side, and in the center, it's a 40, which gives us, of course, 5 millimeters difference will give us 10 millimeters of throw. If you had a bit of a beefier engine, so this one here is, I believe, an 8 horsepower Honda. If you had a beefier engine at 10 or 11 horsepower, 13 horsepower, you could give yourself a little bit more throw. So you could have a 7.5 or a 10 millimeter difference in your eccentric shaft, giving you a 15 or 20 millimeter throw, and it would be able to handle that. My engine, being an 8 horsepower, it's not huge, but it's awesomely paired with the 10 millimeter throw that this eccentric shaft has. Now, this is something that I drew, the eccentric shaft. This is another question that comes up a heap. Oh, where'd you get your eccentric shaft? You know, blah, blah, blah. Any engineering shop can make them. You do not have to be a clever cookie to be able to jump on a lathe and make an eccentric shaft. It's extremely basic. All you need to tell them is your outside diameters for the shaft, the width of the section you need in the middle for the difference in eccentric, and then the actual center diameter. And that's all. Any engineering shop will make them. I couldn't tell you what it cost me, but it wasn't a heck of a lot because it was done through friends. So, yeah, don't expect to pay a heap. Someone will easily be able to make you up that shaft for, around $100, I'd assume. Shouldn't be a problem. Now, one other question that I get quite a bit, that can be actually a little bit aggravating to me, is people say, oh, what's the exact measurement of this? What's the exact measurement of that? The exact measurement of any of it doesn't matter. Use what you've got. So I used recycled C-section steel. So I made it roughly 200 millimeters wide because that's the width of the actual C-section. If you've got that size, then make it that size. If you've got different size steel, well, make it that size. It doesn't matter. It's all good. Use whatever you've got there to make it however you want. It doesn't matter. I recycle all the steel that I use for this stuff is all recycled because I'm very tight. So in my case, this is what I used. In your case, you can use whatever you've got. If you want to copy the exact design, yeah, no worries. Go out and buy yourself some 200 by 75 C-section. You can make it identical. No dramas. If you've got something else laying around, by all means, use that. Doesn't matter. This didn't have to be as wide as it did. It would have been fine to be that wide. The jaw didn't have to be open as wide as it is. It could have been a little bit smaller. And of course, vice versa, it could have gone the other way. Could be slightly larger. That bit does not matter. Use whatever steel you've got laying around based on your budget, and I'm sure that it'll be fine. The only important detail is, have you got the engine horsepower to drive it? That's going to depend on how big you want your jaw crusher. That's going to depend then, of course, how fast you want it to be running. And that's going to, of course, then choose which size pulleys and such that you're going to need for the job. All of the rest of the little details don't matter. Base your build off what you've got available. If you're buying it all new, well, then the world's your oyster. You can make it as large or small as you choose. I think I've covered off all the questions. Without further ado, I've got 2 samples here that need to be crushed. So let's run them through. Now these 2 samples that I've got here from different locations, somewhat close together. This one I refer to as the old pan shafts. There's 7 kilograms of rock in there, and it is bloody hard rock. Very, very hard rock. You can bash it all day and it barely breaks up. This stuff here is from my most recent development called the split reef. It's much softer rock. It will break up. The ore is heavily diluted among the country rock, and it's all very, very soft stuff, so that'll run through really easy. So let's run these two through, and I'll show you how much better this jaw crusher works with that flywheel and the current RPM. Because that ore was so hard, it didn't break everything up into the smallest pieces. It's good enough, but I'll just run it through once more again. That'll get it a little bit smaller. Much better. And the ore from the split reef. Get in there, go on. If it fits in there, it'll crush it up. Doesn't matter what you throw at this thing. If it fits, it'll crush it. If it doesn't fit, well, there's nothing you can do about that. that's it. It will handle anything you can throw at it. As long as it fits in that hopper, it'll smash it to bits. And I've tested it on some excruciatingly hard ore, and it still does it, no worries at all. You might have heard when I was doing that harder rock to begin with, it was doing a bit of a squeaky noise. Now what that is down in here, I've got only 2 points of weld on this inner wear plate. And down lower at the bottom there, where it makes the most contact, this bit of wear plate is actually bending a little bit. It's moving with the jaw as the ore's getting pressed and yanked on or pushed against. So that squeaking noise is actually this wear plate moving a tiny bit. Now it's been doing that since pretty much day dot. You only notice it when you're running really hard rock, and it doesn't really stop anything or change anything. So at this point, I haven't fixed it. I will fix it, however, when I move the jaw crusher off this mount and put it up onto its proper pedestal. I will fix that issue. So just make sure that your wear plates in here are welded in really nice and tight, and there's no movement in them, and you'll avoid that issue as well. Or if you've got thick enough wear plates, you can also drill some holes through and put some bolts in there. That would help. I went with a few little stitches of weld because I don't think I'll ever have to change those wear plates anyway. So what's the point of doing a heap of drilling and adding bolts and such? It's a lot of extra work when it's not really going to save me any time later down the track. So that's it. She works a treat. If anyone's got any more questions about it, by all means, feel free to shoot them through, but hopefully I've covered off as much info as you guys will need. This top flap serves two purposes as well, of course. It stops any rock from flicking back up out the top. So, very handy to be able to do that. As you would have seen, I was sort of trying to cram some pretty big rocks in there. So being able to flip that up and really jam them in there is very advantageous, as well as the fact it'll likely save you from copping a couple of bits of rock to the face or shooting rock out the side and losing good quality ore and affecting your numbers at the end of your sample. Hopefully I've covered everything off. I hope that those of you that are going to take on a build like this or similar will be able to get all the information that you need from me. And I hope that you're as happy with yours as I am with mine. Because, man, I love this machine. It is fantastic. Thanks for tuning in, y'all. See you again soon.